The claim that installing electrical outlets near toilets is in vogue and driven by the expectation of future electric toilets has limited support. While electric toilets exist, they are not yet mainstream and their widespread adoption is not imminent. Most building codes currently do not require electrical outlets near toilets. Installing electrical outlets near toilets poses potential safety concerns such as the risk of water damage or electrical shock. Despite the lack of widespread need for electric toilet outlets, there may be some reasons for their installation in certain cases. Firstly, some homeowners may prefer to install outlets near toilets as a speculative measure in case electric toilets become more common in the future. Secondly, some individuals may find it convenient to have an outlet nearby for charging electronic devices or using appliances like hairdryers. Thirdly, in some cases, outlets may be installed near toilets to maintain a consistent aesthetic appearance in the bathroom. It is not standard practice to install electrical outlets near toilets. There may be limited cases where it could be considered. However, it is important to consult with a qualified electrician to ensure safety and compliance with building codes. It is also advisable to consider the potential risks and benefits before making a decision. When planning any electrical work, especially in a bathroom environment, safety should be the primary concern. Water and electricity create a dangerous combination, so all installations must adhere to the National Electrical Code, or NEC, and any applicable local codes. Article 210.11 C3 of the NEC addresses bathroom branch circuits and states that in dwelling units, at least one 20-amp branch circuit shall supply the bathroom receptacle outlet. This circuit shall have no other outlets. This means that the receptacle near the toilet, if installed, must be on its own dedicated 20-amp circuit. Furthermore, ground fault circuit interrupter, or GFCI, protection is mandatory for all receptacle outlets in bathrooms, as per NEC section 210.8.1. The GFCI is a crucial safety device that detects even small imbalances in the electrical current and quickly shuts off the power to prevent electrical shock. When choosing the location for an electrical outlet, consider the potential for water exposure. The NEC does not provide specific distance requirements from the toilet, but it is wise to locate the receptacle as far away from the water source as practically possible. Avoid placing the outlet directly behind the toilet or in an area where it could be easily splashed. If an outlet is installed in a damp or wet location, it must be protected by a weatherproof enclosure. Wiring methods for bathroom circuits must also comply with the NEC. Typically, non-metallic sheath cable, such as type NMB, is used for residential wiring. However, in potentially wet locations, such as bathrooms, it is important to ensure that the cable is properly supported and protected from physical damage. Where cables pass through metal studs or framing members, they must be protected by bushings or grommets to prevent abrasion. Consider the potential uses for the outlet. If it is intended for charging electronic devices, a standard 15-amp receptacle may be sufficient. However, if it is intended for use with higher power appliances, such as hairdryers, a 20-amp receptacle may be required. In some cases, a USB charging receptacle may be a convenient option. This type of receptacle includes built-in USB ports for charging smartphones and tablets without the need for an adapter. From an aesthetic perspective, consider the overall design of the bathroom. The electrical outlet should be installed in a location that is both functional and visually appealing. Coordinate the color and style of the receptacle cover plate with the other fixtures and finishes in the bathroom. Remember that any electrical work must be performed by a qualified and licensed electrician. Attempting to install electrical outlets without the proper knowledge and experience can be dangerous and may result in code violations. An electrician can assess the specific requirements of your bathroom and ensure that the installation is safe, compliant, and meets your needs. Consider the long-term implications of installing an electrical outlet near the toilet. While electric toilets may not be commonplace today, it could become more popular in the future. By installing an outlet now, you may be future-proofing your bathroom for potential technological advancements. However, it is important to weigh the potential benefits against the risks and costs. If you are unsure whether to install an outlet, consult with an electrician and discuss your options. They can provide valuable insights and help you make an informed decision. Even if an electrical outlet isn't installed near the toilet initially, plan for the possibility of future installation. This could involve running conduit or leaving extra wiring in the wall, making it easier to add an outlet later without major renovations. This anticipatory approach can save time and money in the long run if electric toilets or other electrical conveniences become more desirable. Electrical safety is paramount, especially in a bathroom environment. Always prioritize safety over convenience or aesthetics. Ensure that all electrical work is performed by a qualified electrician and that all installations comply with the NEC and local codes. By taking these precautions, you can enjoy the benefits of electrical outlets in your bathroom without compromising your safety or the safety of others. In addition to electric toilets, other bathroom appliances and fixtures may require electrical power in the future. For example, some modern bidets include features such as heated seats, warm air dryers, and adjustable water spray. These features require an electrical connection, so an outlet near the toilet could be useful for powering these types of devices. Furthermore, advancements in smart home technology could lead to new bathroom devices that require electrical power. For example, smart mirrors with built-in displays and voice control could become more common in the future. These devices would need an electrical outlet to operate, so having an outlet nearby could be beneficial. In conclusion, while there is no widespread need for electrical outlets near toilets today, there are several reasons why homeowners may choose to install them. These reasons include anticipatory planning, personal convenience, and aesthetic considerations. However, it is important to consult with a qualified electrician to ensure safety and compliance with building codes. It is also advisable to consider the potential risks and benefits before making a decision. Before deciding to install an electrical outlet near a toilet, consider the local electrical codes. Different municipalities may have varying regulations regarding the placement and type of outlets allowed in bathrooms. Check with your local building department or a qualified electrician to ensure compliance. Electrical outlets near toilets should be installed with tamper-resistant receptacles, or TRRs. These receptacles have a built-in safety mechanism that prevents children from inserting objects into the slots, reducing the risk of electrical shock. Tamper-resistant receptacles are required by the NEC in dwelling units and are a simple way to enhance safety in bathrooms. When installing an electrical outlet near a toilet, consider the placement of other bathroom fixtures and appliances. The outlet should be located in a position that does not interfere with the use of the toilet, sink, shower, or other fixtures. It should also be easily accessible for plugging in and unplugging devices. In addition to standard electrical outlets, consider installing a combination outlet with both electrical and USB ports. These outlets provide the convenience of charging electronic devices without the need for a separate adapter. They are becoming increasingly popular in bathrooms and other areas of the home. If you are concerned about the aesthetic appearance of an electrical outlet near a toilet, consider using a decorative cover plate. These cover plates come in a variety of styles and finishes to match the decor of your bathroom. They can help to conceal the outlet and make it blend in with the surroundings. When planning an electrical installation, it's crucial to consider the load calculation for the circuit. The load calculation determines the amount of power that the circuit will need to supply. This calculation takes into account the wattage of all the devices that will be connected to the circuit, including any potential future devices. By accurately calculating the load, you can ensure that the circuit is properly sized and can handle the demand without overloading. According to NEC Article 220, branch circuit load calculations are vital for safety and performance. The general lighting load for dwelling units is typically calculated at 3 volt amps per square foot, as per NEC Table 220.12. For small appliance branch circuits, such as those serving kitchen and dining areas, each circuit is calculated at 1500 volt amps. In bathrooms, the 20 amp branch circuit dedicated to receptacle outlets is typically sufficient for powering various devices. However, it's still essential to consider the potential load from electric toilets or other future appliances. Another important factor to consider is voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. This can be caused by long wire runs or undersized conductors. Excessive voltage drop can lead to dimming lights, slow running motors, and other performance problems. To minimize voltage drop, use appropriately sized conductors and keep wire runs as short as possible. NEC Chapter 9, Table 8 provides guidance on conductor properties and allows for calculating voltage drop based on wire size, length, and current. When installing wiring in a bathroom, it's important to protect it from physical damage. Wires should be run through conduit or behind walls and ceilings to prevent them from being accidentally cut or damaged. In areas where wires are exposed, such as in unfinished basements, they should be protected by conduit or other protective measures. NEC Section 300.4 provides requirements for protecting conductors from physical damage. In some cases, it may be necessary to install a surge protector to protect electronic devices from voltage spikes. Surge protectors can help to prevent damage to sensitive electronics caused by lightning strikes or other electrical disturbances. They are particularly important for protecting expensive devices, such as computers, televisions, and home theater equipment. There are several types of surge protectors available, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect all of the circuits in the house. Point-of-view surge protectors are plugged into individual outlets and protect only the devices that are connected to them. For bathrooms with electric toilets or other sensitive electronic devices, a combination of whole-house and point-of-view surge protection may be the best option. When selecting a surge protector, look for one that has a high surge current rating and a low clamping voltage. The surge current rating indicates the amount of current that the surge protector can handle without failing. The clamping voltage indicates the voltage at which the surge protector will start to divert excess voltage away from the protected devices. A lower clamping voltage provides better protection. Ensure that the surge protector is listed by a recognized testing laboratory such as Underwriters Laboratories or ETL-SEMCO. This ensures that the surge protector has been tested and meets safety standards. Regularly inspect surge protectors to make sure they are functioning properly. Some surge protectors have indicator lights that show whether they are still providing protection. If the indicator light is off, the surge protector may need to be replaced. In addition to surge protection, consider installing an arc fault circuit interrupter or a PSI breaker. PSI breakers are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when wires become frayed or damaged, or when there is a loose connection. PSI breakers can quickly shut off the power to the circuit when an arc fault is detected, preventing a fire. PSI protection is required by the NEC in many areas of the home, including bedrooms and living rooms. While PSI protection is not typically required in bathrooms, it may be a good idea to install an PSI breaker for the bathroom circuit, especially if there are young children or elderly individuals in the home. Like GFCI receptacles, PSI breakers are relatively inexpensive and easy to install. The NEC has undergone several revisions, and it's crucial to stay updated with the latest edition. Electrical codes are updated regularly to reflect new technologies, safety concerns, and best practices. By staying informed about the latest code requirements, you can ensure that your electrical installations are safe and compliant. Obtain a copy of the latest edition of the NEC from the National Fire Protection Association or NFPA, or consult with a qualified electrician or electrical inspector. In addition to the NEC, many states and local jurisdictions have their own electrical codes and regulations. These codes may be more stringent than the NEC, so it's important to be aware of them. Contact your local building department or electrical inspector to learn about the electrical codes and regulations in your area. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you're not comfortable performing electrical work yourself, hire a qualified and licensed electrician. An electrician has the knowledge, skills, and experience to safely and effectively install electrical outlets and other electrical components. An electrician can also ensure that your electrical installations comply with all applicable codes and regulations. When hiring an electrician, check their credentials and make sure they are licensed and insured. Ask for references and check online reviews to get an idea of their reputation. Get a written estimate before the work begins, and make sure the estimate includes all of the costs, including labor and materials. In addition to the considerations mentioned above, it's also important to think about the environmental impact of electrical installations. Choose energy-efficient lighting fixtures and appliances to reduce your energy consumption and lower your carbon footprint. Consider using renewable energy sources, such as solar panels, to generate electricity for your home. Dispose of old electrical equipment and materials properly to prevent pollution. Electrical outlets near toilets may be a trend driven by anticipation of future technology or simply a matter of convenience. However, safety and compliance with codes must be prioritized.